Welcome everyone. We're just doing some work out of the textbook. We're doing an exercise on squares and the square root. Okay. Now this kind of work goes back many thousands of years. The Babylonians knew about the square root and could approximate that correctly to 5 decimal places or something. So the Greeks did a lot of this work too. They understood squares and they understood the square root, but the irrational numbers that were generated from the square root caused them issues. But hopefully there's a few things I can show you that caveat again, because what I'm going to show you is an approximation in a lot of cases. There's some more complicated mathematics that increase the accuracy of what we're about to do. But today we're just going to play with squares and then think about the square root of that number. For some numbers that'll drop out nice and easy and we'll be working with whole numbers. For other ones I'll show you a technique where we can approximate the square root. Importantly, using our knowledge of squares. Alright, so I think this is going to be a fun lesson and there's certainly a lot to learn. So as I work, I want you working on a pen and with a pen and paper and following along. Now for this final part of the chapter here, I think we're looking at squares and square roots. And I honestly hope that we spend a bit of time on this because it's such a useful skill, all right? To be able to identify square numbers, they're just a particular type of number. It's kind of easy to work out what they are. So we could say 9 to the power of 2, or we could say 9 squared is often what we say, okay? So that little power or index there is indicating we can think about this as 9 times 9, that's equal to 81. So another way I like to represent it is this way here. Draw a little box and the dimensions on the box are the same, so we could have these little ticks here if we wanted to, but I'll just put the numbers and then I'll write 81. This is like the area model, okay? That's useful in itself because it's getting you used to some of the other units that are coming up. So if you want to work on squared numbers, you can find a button on your calculator that just literally says x to the power of 2, and that says any number raised to the power of 2. If you want to square that number, that's a button you hit, and you just put in 9 squared and hit the button, okay? And that'll deliver you your answer. So that's okay, but let's think about square numbers. And I'm just going to across here draw a bit of a number line here. Put 0 down one end. We've got 1 here because 1 times 1 is 1 and 1 is a square number, okay? Our next square number here is 4 and that's 2 times 2. And then we have 9, which is 3 times 3. We have 16 here, which is 4 times 4. 4 times 4. I was thinking about the next number. We've got 25, and that is 5 times 5, 25. And here we've got 36, and this is 6 times 6 is 36. So they're all square numbers. I think they're really important signposts that you need to learn. And once you see them, life is really easy with maths. So get to know them, get to learn them. And I think they've been really kind to you in the textbook. They're keeping everything nice and neat here. So a lot of your solutions, particularly when you take the square root, okay, there's a button on your calculator that looks like this. It's got the square root sign and a box underneath. When you press that, you can move your cursor around and put the numbers that you want under the box. So, for example, the square root of 36 is going to be a nice, neat solution, and that's 6. So what are we actually talking about when we do the square root? So we've got a number like 36, and we know its dimensions are 6 by 6. And the way I think about it is that see, that's two-dimensional shape. When we take the square root, I want to know what the one-dimensional length of this shape is. If I only had the chance to give one number that describes the square, that number would be 6, because all the sides are the same length, they're all 6. So what's not shown in any of this, they don't put a little 2. Okay, so that is not shown on your calculator, that is not shown in your book, but sometimes I write it in just to demonstrate this point that I'm about to show you, because I've got a line up here to indicate that these are the opposite operations of one another. Okay, so if I took the square root of 36, which is a square number, that's equal to 6. Now let's set it up a little bit differently. I'm going to put the little 2 there, and I write this as 6 squared. Now technically what this means is those things cancel each other out. So my, if you like, one-dimensional length, or the root of that shape, is 6. Okay, so I'm just pointing that out to you as a way of showing you what's going on. So I'm going to pause the video. I've got a couple of other questions that I want to show you. I'm going to leave the number line, but I'll just remove everything else. Now, some of the questions in your textbook, you're most welcome to use the calculator and set this up and just practice, okay? Because what's going to happen when you put this in here, see how that square root sign, I've just made it longer, the tail there, I've made it longer. And underneath here, I'm putting all this work. And you can type it in your calculator and the answer will be 10. Okay? So we've got our answer, and to be honest with you, the answer is not the most important thing here. What I want you to try and understand is the concepts here. What we've got underneath, and we could possibly put brackets around this and use BODMAS to tell us to do everything inside the brackets before we took the square root of this. And what we find is 8 squared, I haven't got it there, but that's equal to 64. Plus 36, and together that's equal to 100, right? I'm just putting the square root sign back over there because that's something we've got to do next. So the square root, let's add that together, and in there 100, and the square root of 100, which is just 10 times 10. So the root dimension of that will be 10. Okay, so there's our answer, 10, and we'll just work through that by hand. Now, that's not even the most important thing I want to show you. I want you to think about how we got there. And if I had a square here whose dimensions were 8 by 8, that's 64. And I've got another square here who's 6 by 6, 36. Now, imagine we're going to rearrange all this and make it fit into here. And how do we do that? And we do it, let's just pretend they're counters. Let's add on a couple of rows here. So on that side, we're going to add 8 and 8. So there's 16 counters there. And if we put 16 across here as well, That takes us to 32, so 36 subtract 32 will leave us with 4 counters left. And that's good because look what's needed down in the corner here to make the next square. We need 4 counters to fit into there. And so what have we got at the end of the day? We have, might pay to, now that we've rearranged some of that, might pay to remove these guys here. And let's take those off there. They were 8 plus another 2 rows on each side. So what do we have? We have 10 by 10 and there's our 100. And if we're just looking at the root dimension of that, the one-dimensional length that describes a shape, there it is, it's 10. So there are ways to think about that question. So I'm going to do one more just to reinforce that idea. I said one, but I've actually got 2 things I want to show you. So we're looking at the square root of 5 squared subtract 4 squared. Okay, be really careful if you do this on the calculator. Make sure the line extends out over those things because you'll get a different answer if it doesn't. So now that we've done that, I'm thinking about this using my knowledge of squares. I've tried my best to leave the number line down here so we can use it as a reference. So 5 squared is 25. So this is going to look like the square root of 25 subtract 4 squared is 16. Okay, so do the work underneath the square root sign, do the subtraction or the difference, and the answer there is 9. Now that's nice because that turns out nice and neat. Okay, so what are we doing there? Let's try and understand this through a different way. Okay, so we have 5, if this is 5 squared, I'll just change the color of my pen. Inside here we've got, inside this square, we have a square whose dimensions are 4 by 4. All this in here, and that's equal to 16. And we're saying what is left? Well, we've got 4 there, we've got 4 there and 1 in the corner, so that's equal to 9. Okay, and 9 is a square number. So what does 9 look like? 9 looks like this. So we've got to take the square root of it, and so what's that dimension there? That is length 3. And that's how we end up with our answer over here. So hopefully you're starting to see this. Everything, as far as I can see, all the questions are set up nicely to allow you to play around like this. So one last question here, and I've got some monster number looking like this. And it looks terrible until I realize that there's 2 squares hidden in here. So I'm seeing this as 49 times 100. And I've got 7 squared in here. 7 squared times 10 squared. And here's a little trick when you're doing this by hand. You can separate these out and write it like this if you like. 10 squared. There's a little 2 there because what I'm going to do is cancel these things out here. So that's equal to 70. Alright, there's your final answer. Okay, so you can do that work by hand depending on what you see. I'm hoping that you see the squares, and I'm hoping that you understand what the square root actually means. Alright, thank you.